Hi, my name is Sai Krishna. So let us look at question number 1. In question number 1, we are told to collect the definition and simple properties of the following stochastic processes and explain what we understand from about these processes. So let us look at the solution for this. So here in the question 1, part 1, which is Poisson's process, we can define Poisson's process as probability of t1 comma t2 for equal to k as e power minus lambda t power k by k factorial. If the intervals t1 comma t2 and t3 comma t4 are non-overlapping, then the random variables n of t1 comma t2 and n of t3 comma t4 are independent. Okay, so these are the first two properties of Poisson's process. Let's look at the third property. So the third property states that at a moment t, where there is no more than one Poisson's point, so the points ti, we can form a stochastic process x of t equal to n of 0 comma t. So I have basically written down the first order probability masses, p of x of t equal to k as e power minus lambda t power k by k factorial. Mean of x of t is lambda t, autocorrelation as lambda square t1 t2 plus lambda minimum of t1 t2. Autocovariance c of t1 comma t2 as lambda square t1 comma t1 t2 plus lambda minimum t1 comma t2 minus lambda t1 into lambda t2. So by Poisson's process, I basically understand that the mean of the Poisson's process lambda t is a linear function of t. Basically, it matches our expectation that the expected number of the longer we wait, the expected number will be larger. The autocorrelation function contains a term minimum of t1 comma t2. The correlation minimum of t1 comma t2. So basically which comes at the this minimum comma t2 comes from the property of independent increments. So this is what I understand from the first Poisson's process. So second we are told to discuss is about Poisson's increments. So Poisson's increment can be defined by y of t equal to this equation, where x of t is a Poisson's process. We know that the mean is e of y of t equal to lambda, and the first order probability masses is defined as p of y of t equal to n by epsilon, and by this equation. The autocorrelation of the Poisson's increment is r t1 comma t2 is this equation when mod of t1 minus t2 is greater than or equal to epsilon, and this equation when mod of t1 minus t2 is less than epsilon. So coming to autocovariance, the autocovariance so similar to what we have observed in autocorrelation depends on time intervals mod of t1 minus t2 greater than or equal to epsilon and less than epsilon. The values are 0 and this respectively. So my understanding of Poisson's increment is that it is introduced to prepare us so this is basically used for Poisson's impulse process. Okay, and we can also observe that for the autocorrelation, which is basically this term. So this term is basically a triangle whose area is lambda and is independent of epsilon. So as epsilon tends to 0, the impulse will stand and the area becomes equal to lambda. Coming to the third part, which is point impulse process. So the point impulse process, z of t can be defined as d by dt of x of t, where x of t is a Poisson's process. So mean is lambda, autocorrelation is lambda square plus lambda delta of T1 minus T2, and autocovariance is this equation given here. So basically my understanding of point impulse is that z of t minus lambda basically has zero mean, and that autocorrelation r of t1 comma t1 comma t2 is lambda delta of t1 comma t2. So this implies that basically this is a white noise. Yeah, so this is what I've understood from point impulse process. For the semi-random telegraph signal, semi-random telegraph signal can be defined as this equation, and it can by using the help of this equation, and for basically k, with when it is even it is 1 x of t, and when k is odd it is -1. The mean is e to the power of minus 2 lambda t. The autocorrelation is r of t1 comma t2 is basically this equation. The autocovariance is this equation. Okay, so basically my understanding is that as t tends to infinity, the mean tends to 0 for semi-random telegraph signal, and for autocorrelation, as mod of t1 minus t2 tends to infinity, tends to 0, sorry, as the mod of t1 minus t2 tends to infinity, the autocorrelation tends to 0. This is what I've understood from the semi-random telegraph signal. So let us look at the random telegraph signal. For the random telegraph signal, basically I have basically we can write y of t as a into x of t, and probability of probability a equal to 1 and a equal to -1 are equal to half, where x of t is a semi-random telegraph signal. Okay, and the mean is 0. The autocorrelation is given by this term, and the autocovariance is given by this term. So my understanding of random telegraph signal is that p of y of t equal to 1 and p of y of t equal to -1 are half, and this implies that y of t can be a strict sense stationary process, and e of y of t is a constant. This also can imply that it's a strict sense stationary process. So let us look at the random walk. So the random walk, the mean is given by e of x of t equal to 0. Autocorrelation is given by this term, and autocovariance is given by this term. So basically, what is random walk basically means that whenever, say for example, we are tossing a coin n times, and k implies the number of heads in the n tosses, then x of n t can be written as 2k minus n into s. This is basically what I've understood from the random walk. So in the random walk, we can also see that as n tends to infinity, we have Gaussian density, and that's what I've understood from random walk. Coming to Venus process, for the Venus process, so mean is 0. The autocorrelation is given by this term. The autocovariance is given by this term, and so we can also say from random walk we can define what is Wiener process as this equation, which is Wiener process equal to limit t tends to infinity s square by t tends to alpha and n tends to infinity x of t. So basically my understanding of Wiener process is that it basically describes a physical phenomenon in which some quantity is constantly undergoing small but random fluctuations. So this is what I've observed and understood for the question number 1. Thank you.